Okay, before we start page 3, which has multiple problems, let's just look at this little flow chart on the very back, and this is on page 4. Okay, when we're solving, we want to ask ourselves, because we have multiple different kinds of equations here. We have equations that have logarithms, and then we have equations where the variable is in the exponent. And we know right now that exponents and logs are inverses of each other, right? So you could refer to this flowchart. This is basically your toolkit, okay? Is it an exponent or is it a log? So if the equation has an exponent in it, you want to ask yourself, can you make it the same basis? That's what we did the very first day when we were solving exponential equations. We want to make the bases the same, and I'll show you some examples of that on the next page. If they can't be the same bases, then we would be using the logarithm. Okay, and so these are two different examples here, but I'm going to be going over different ones. If it's a logarithm, then you want to ask yourself, do all the terms have a log? If they all have a log, can we consider making them, combining those logarithms, right? And using that idea of the properties of logarithms, instead of expanding it, making it into a single logarithm. And then if they don't all have logarithms, we want to consider getting the logarithm alone so that we can use the inverse, which is that whole process of how we solved in the last few examples. Okay, so we might need more paper for this, and that's okay. I have extra scrap paper. So you might get out some extra scrap paper, and we'll do these one at a time. Okay, so here, if we have two logarithms, I mean, what do you see right away? And this is, by the way, all of this problem solving, I'm not going to be able to tell you, like, always do it this way. We're going to have to use our knowledge of what we know about logarithms. So what can you see is a strategy that you might be able to use if you have two different logarithms here? Yes, and it's actually the opposite of expand. It's combine it, right, into a single logarithm. So because we're adding, what are we going to do to make this into a single logarithm? Log of x times x minus 3, correct? Equals 1. Okay. Now, what could I do with that? This is all a single logarithm now, right? So to get rid of the log and to get the x out of the log, we might use our definition of logarithm. To get the variable out of the log, I can use the definition of logarithms, which says the base. Well, what's the base here? 10. What's the power? 1 equals x times x minus 3. Oh, that seems like an easier equation to solve now, doesn't it? Put this paper back here. So what could I do to solve that? Yeah, it's just 10. You're right. So I have 10 equals, why would I go x squared minus 3x? Why would I do that? Because of distribution, right? What can I do to solve this? This is a quadratic. How would I solve it now? I would have to, any quadratic, I have to set equal to 0 to solve. And this is where I might end up running out of space. So that's why I have my extra paper here. How do you solve a quadratic? Factor. Okay, and so we get x. What are our factors? Does anybody know? 5 and 2. And what are your signs? Minus 5 plus 2. And so what does that mean x equals? See, look at this. You're great at this. Now, you forgot to read the instructions because they were actually on, and I forgot to read them too, they were on the bottom of the previous page. It says, solve the equations, round to 2 decimal places. What it also should say here is, does anybody know what directions I'm going to say next? Yes, you need to check, okay? Because there are 2 solutions here, but do you remember what the domain of the logarithm is? What values of x, what are the only values of x that you can have? You can only have positive values. So that means right here, this is an extraneous solution. You'll find that out if you go to check it. And I would say use your calculator to check it. I don't know the log of -2, but if I type in log of -2 plus log of -2, oops, that's not -2, -2 minus 3, I should get 1 when I press enter. Oh, we get an error. That's because, remember, the domain was from 0 to infinity. When we graphed the logarithm, it looked similar to this. Remember, it had an asymptote? Yeah? So we would exclude -2, and then go ahead and clear that out and go ahead and check log of 5 plus log of 5 minus 3, which is log of 2. You could do it either way, log of 5 minus 3, or you could just enter that in as log of 2, and you get 1. Okay, so your check, if your check does not work, it could be you're entering it wrong, but it also might be that we have an extraneous solution. So our answer here is only 5. And do me a favor, okay? If you check it using your calculator, just show me you checked, right? Calculator, check, and I'll be happy with that, all right? Then I know that you know that I know that we both know that you checked. All right. I would like you to always be checking, always be checking. That'll be fine with me, yeah. If you don't, I would rather you check than not check. Okay, what should we do to solve this one? What would you do? Isn't this very similar to this? Yeah, combine into a single logarithm. So we have log base 5 of x divided by 4, that's okay, equals 2. And now, what could we do from here? Yes, we can. How would you switch it? So 5 squared, x over 4. Excellent. 5 squared equals x over 4. That's using the definition of logarithms. See here. Switching it up, using the base to the power equals the number. And now what could you do to solve next? Times 4 on both sides. X equals 100. Good. How'd you get 100? Good. 25 times. And now go ahead and you can check that on your calculator. So I'm going to assume it's right, but we're going to do a calculator check. Okay. So go ahead and do that at your leisure. At your leisure. Okay, what should we do to solve this one? This one looks very similar here. What would you do? Can you tell me what step to do first? So x plus 2 times x minus 5 equals 3. Okay, and now what? Well, can we get these x's out of the logarithm? Same exact process, right? 2 to the power of 3 equals x plus 2, x minus 5. Now, is it true that my answers are just x equals -2 and x equals 5? No, because this has to be set equal to what? 0. So 2 is the base, 3 was the exponent, 2 to the third power is 8, equals, and then what would you do you'd have to FOIL this, right? X squared minus 3x minus 10. Is that right? What would you do to get x by itself, or before you factor? You would have to set it equal to 0. So we get 0 equals x squared minus 3x minus 18. And can you come up with the factors of that? X minus 6, x plus 3, x is equal to 6, and x is equal to negative 3. Well, we already know that negative 3 isn't going to work, and I'm just going to, in order to save time, I'm going to let you do your checks, okay? So right here we have x equals 6, and I really hope that's right, but I feel weird about it by not checking, but I'm just going to assume that you're going to check for me. Okay. What should we do for this one here? Can I rewrite it can I combine it? What can I do? Yeah, well, here's the thing. If I say that log of 3x equals log base 3, sorry, not log of 3. Log base 3 of x equals log base 3 of 7. Can you tell right away what x has to be equal to? Has to be equal to 7 in this case, right? And here the same thing's true. I say log base 3 of this is equal to log base 3 of this. Therefore, x plus 12 has to equal 4. I'm sure there's a much more complicated way that you could solve that, but essentially it's kind of like the same question we were talking about before. 1/2 equals x over 2. What does x have to be? It only has one option. And you see how the log base 3 of this is equal to log base 3 of this. Therefore, those two things have to be equal, right? So now what can we do to solve? Subtract 12. And we get x equals negative 8. The only thing is that that's actually okay, because if we plug negative 8 in here, we're not going to get log of a negative number, right? So x can be negative 8. Essentially, yes. Yeah.